Welcome to another video explaining the universe using the particle model. Today's video is about the value of VG1. I've done an experiment, made several reports, been trying to get to that value by doing the experiment. But before we go into the details of that, a word about the book that Dave and I wrote. The name of the book is Principia Mathematica II. You can get it from Amazon on hardcover, paperback, or ebook. And we did recently, just yesterday actually, we did a video presenting our book, the history of it, how we got into it, and some of the key points of the book. And if you're interested, you can find that on the CNPS website. But we're going to go ahead here with the report. This is really my final report of this particular experiment. This is the test circuit I used. I have a variable power supply, 2 shunt resistors used for measuring current here and current there, and then I measure the resistance and voltage across that resistor to get the current here. And then I'm going to discuss what that current should look like as it goes through S1, R1, and that's supposed to be S2. So this, there are actually, I have presented 3 different sets of equations. There's the standard set of equations for that circuit, which say that the current through S1, R1, and S2 would be the same. This is simply Ohm's law. You divide the voltage applied by the sum of the resistances, and you get the total current, and that's the current that goes through each of the resistors. But when I develop an equation using the particle model, in this case without the speed factor, you get a decreasing current. That's because you're losing G1s through this resistor before you get to that one, and you lose more here before you get to this one. And these are that's the current levels you would expect if this set of equations were true. I did, however, apply the speed factor because as the G1 particle goes through any component, it speeds up and slows down. And depending on the voltage applied, it can speed up faster and slow down more. And I made a prediction as to what the current through these S1, R1, and S2 would be. And it has this V-shaped curve. It goes way down for the speed through the R1 causes it to go down. Because it passes on more to the S1, it goes back up again. So these are the expected results predicted by 3 different sets of equations. And the question is, what do the measurements say? Well, this is developing the VG1 equation. That's down here. I've been through this where the VG1 is equal to this value divided by SR1. And I'm not going to go through that detail again, just to point out that there is an equation, and I will attempt to solve these equations using the measured data. So I did 18 tests. I picked 3 different resistors for R1, and I picked 6 different voltages. That's 3 different resistors, 6 different voltages, making 18 tests. And I set up, I have to assume certain values because I don't know what it is. This is a typical value for volts per G1. The number I just showed here earlier, IFR, that is another, I pre-calculated that using a simple circuit. I had to estimate the G2 mass of the R1 resistor and the S1 and S2 resistors in order to calculate a speed factor. So these are assumed values. These are the 18 tests I did. And in general, this is the results. Now, since my last report, I had found that I actually did make some mistakes in my spreadsheets, and I went through them more thoroughly, fixed the problems, and now I'm telling you now what the corrected waveforms are. But in general, they're very close, although they've got better. This is circuit 1 with 3.9K, and I'm claiming through a visual inspection that the blue, which is the measured value, is V-shaped in all these, but these two don't. I mean, this lines up great. This value and this value is good, but this value is way off. And so I'm saying these four are good, these two are bad, and you kind of get that kind of a correlation. Circuit number 2, we used a 2.2K resistor, and this one was clearly wrong. The measured value didn't have, all of these have a V shape, but this one didn't. This value appears to be wrong, so this is bad. I'm claiming 5 out of 6 are good. And finally, the third circuit with a 1K resistor. They're all V-shaped. Everything looks, maybe, yeah, this is a little further off than the others, but this one is almost dead on. Amazing how close that is. And I'm claiming a 6 out of 6 match. So basically, what I ended up with is about 15 out of 18 matched the equations that were with the speed. So, it says that the current through that circuit does not follow the standard equation, doesn't follow the TPM equation where I don't include speed, but where it does match the TPM equations so that's a good correlation. This to me is a very strong positive result. But then again, I had to find this value. Besides doing it, looking at it visually, that's pretty subjective. You could come up with your own conclusion as to what percentage passed and failed. So I decided to do a percent match. That is, I'm going to take the measured value, subtract the calculated value, divide it by the measured value, and see how close the values come in percent. And I'm going to say that if it's greater than or equal to 0.5%, it's bad. And so here's all the values after you do this percent match. And you can see here that this is 5%, 7.8%, 2%, but that's the bad one. That's the one where the measured value wasn't right. And it dropped. If you remember, it was high, went down a little bit, and then dropped even more. But nonetheless, these red ones are all greater than 0.5%. And out of the 18 sets, there's 1, 2, 3, 4, 5, 6, 7 of them are bad. So that leaves 11 out of 18 that match on a percent basis. And that's a pretty accurate, that's looking for a very tight response. I'm wanting it to be very, very close. And so although 61.1% isn't very comforting, if that percentage depends on the threshold that I picked. Well, then I finally calculated VG1. What I did was I took the measured value of the voltage applied. I didn't just take 5 volts. I took whatever the measured value was a 5 and 10 And then I took the measured value of resistances and I plugged them into my spreadsheet and recalculated that, and then tried to solve for VG1. Well, if you look at this, I only did this right here for circuit 3. And with the value I got for VG1 is close to 0.1 in all cases. And I'm saying, whoa, no, that's not right. My equations that I say are valid to give me the value of VG1 are just returning the same value. Of course, I use VG1 in that calculation. So I said, I know what I'll do. I'll put 1 volt per G1 in that calculation. And I redid this spreadsheet. I'm not showing it, but it came out close to 1, just like this one came out close to 0.1. The equation I developed just gives me the VG1 back that I had in the first place, which means those equations, they're not independent equations enough to give me the answer. So I'm kind of stuck with that. I have to go back and relook at the equations. And I've been at this for quite a while, and I think it's time for me just to let it go. By the way, in terms of the percent match, I took this first column of the circuits and I made a scatter plot. And you can see here that the 5 and 7 are way out. And there's 3 of them here that are more than 0.5%. This is a 1% line. So these 3 are more than 0.5, and so is this one over here. But the interesting thing about this and why I'm showing is that the first 6 entries here are for circuit 1. And I've applied 5 volts, 10, 15, 20, 25, 30, and I did the same thing here, 5, 10, 15, and so on. So this is 5, 10, 15, 20, 25, 30, and you get this kind of, but what's interesting here is that you start with the circuit 2, 5, 10, 15, 20, 25, 30. It kind of increases as the voltage goes up. The deviation, the percent match increases. There's a clue here, and it seems interesting that I can follow up in the future. I did the same thing for the percent match of the second shunt resistor. This is the one that had this -2. It has minus values, so here's 0 up here. And the -2 is down here, and the next 3 are up here. And here's your 0.5% line and 0.5%. So most of them are here, except those in red. Keep in mind, yet I'm still using 0.5% as my theoretical guideline. And then finally, here's the resistor R1, the percent match. And this looks like it's all over the place, but keep in mind the scale, the way spreadsheet does these charts, it stretches this out to put the points there. This is only 0.35% off, worst case, negative 0.1% off, worst case. This is very good, even though the plots are all over the place. These are all well below 0.5. There's the 3.5, and I don't know. I guess the -0.1 is right about there. So very good results as terms of measured voltage versus calculated voltage using TPM equations. So the results are that the measured values, except for one, that 15 volt, the second circuit, 15 volt, it dropped off. This was way down. 17 of them matched this, did never match this, never matched that. Well, what about VG1? Well, I think this is where I made my mistake. I was thinking that this was a constant and would apply as a general constant, when in fact it contains a VG1. and ended up giving me VG1 right back again when I used that number. So yes, I'm putting this project on hold. I think the results are good. I got a good match with measured values. I just didn't get the VG1 value. My name is Bob D. Hilster, and I am your particle model guru. If you have a question, ask Particle.